Hey everyone, welcome to our day of learning about machine learning at scale, machine learning in the data center, and how that reflects on the future of the data center. I want to thank Intel for making this possible. We're going to be looking at their OneAPI project, and to start, we have a roundtable that we are going to have with some people who know a lot about the end-to-end AI tool chain, the platforms that are being used, what we're seeing and what we're expecting to see. So joining us is Saumya Satish, a product manager for AI software products at Intel. Hey, Saumya.
Hey, hi, Alex. Nice to be on the show.
Thanks for joining us. And Rachel Roumeliotis, Vice President of AI and Data at O'Reilly Media. Hi, Rachel.
Hey there, happy to be here.
Great to have you. And Janakiram MSV, Principal at Janakiram and Associates, a longtime contributor to the news stack and someone we really depend on for insights and expertise. Thank you for joining us, Johnny.
Hi, Alex. Glad to be here.
Great. I want to get started really quick, but before I do, I want to let everyone know that you are free to ask questions, and we'll answer them the best we can in our discussion. So please submit your questions. You can do that right here in what you're in the screen you're looking at, and be able to provide them, and we'll make sure we get them to the guests. So I want to just start by kind of giving an overview of how we're thinking about this new world. And, you know, Johnny, we were talking a lot about this before, and we were actually having a conversation with the rest of the group here about how fragmented the market has become and how we're seeing a lot of choices out there for developers on how you think about training and inference. You know, AWS has Neuron, Intel and Microsoft are building an FPGA, while NVIDIA has CUDA, and Google has their own TPUs. So as a developer, it's difficult to envision a scale out model. And so what's your perspective on that right now?
Absolutely, Alex. While machine learning, deep learning, and AI are getting a lot of attention, it's also a huge challenge for an average developer to get started with that, because all the way from the chips and the hardware to the highest level, which is the library, there are too many choices, too much of fragmentation, and too many complex jargons that the developers have to deal with. So a lot of innovation has been happening in the public cloud. And obviously, the top three hyperscalers have been investing heavily on machine learning. So we have Amazon SageMaker, which is the AWS managed offering. We have Azure ML. Then we have Google Cloud AI and IBM Watson Studio. So these are the platforms that are basically encompassing and abstracting the underlying pieces. But that doesn't really simplify the process for the developers. In fact, that brings in another layer of choice, and along with that, a little bit of a confusion on what to choose, how to choose, and how to get started. So on the public cloud, we have these ML platform as a service offerings that are offering Jupyter notebooks, that are offering TensorFlow, PyTorch, MXNet, and all these frameworks, containerized solutions. So that's a pretty good progress in the last 2 or 3 years that we have seen. Now, cloud is like the powerhouse to train models, but once the models are trained, they are actually going to be put to use mostly at the edge. Now, edge is going to be running in a very constrained environment. We don't have the luxury of running multiple cores of CPUs and large power supply and bandwidth and so on. So when the model is transferred over to the edge and used in production for inference, the real challenge starts. There we have a variety of hardware layers. You know, for example, NVIDIA has this Jetson family of products. Intel has the NCS, the neural compute stick, and then the Myriad X VPU. And Google has Edge TPU. And there are a lot of other AI accelerators, predominantly targeting the edge. And each of them have their own libraries and their own runtimes. So the job of an ML engineer or a developer doesn't end with training the model. It again moves on to the optimization part, because I have to make sure that the model that I trained in the cloud is optimized and accelerated for the edge. And that's another pipeline that I need to deal with. And this whole mix reminds us of software engineering of 80s. We are dealing with the same complexity and same challenges. It's almost like starting it all over again, because everything that we have solved for traditional software engineering and software development life cycle, we are seeing that all over again in machine learning. Now, what we are waiting for and what is actually going on right now is bringing in some of the best practices of software engineering and the more recent trends of cloud native to machine learning. So that is where machine learning meets containers. And we are seeing a huge explosion of containerized machine learning models and Kubernetes becoming the orchestrator. And when Kubernetes meets machine learning, we have best of both worlds. Machine learning is highly parallelized, and it talks about data parallelization by taking advantage of multiple cores. And then we have Kubernetes, which is the distributed scheduler, and it is very good at running jobs at scale. And that's where is the inflection point for ML. And the science of dealing with the cloud native world of Kubernetes and machine learning, model management, and all of that is taking us into the domain and the realm of ML ops,
Right.
where we bring in the DevOps capabilities into machine learning and extend CI/CD to continuous training, continuous inference, and continuous model monitoring and all of that. So it's a very exciting time. At the same time, it is overwhelming for a lot of developers.
Yeah, I would love to follow up on that with Rachel. And Rachel, we did get a question about, these end-to-end environments, and so what it's look like for an ML software pipeline. Question from our own Libby Clark here. I think it's a relevant question, kind of what Johnny's talking about.
Yeah, so I think there are a plethora of choices. And I don't think that what we found, starting with the cloud, what we found is that there usually an organization is multi-cloud or hybrid cloud, right? So you're going to have to be familiar with a multitude of different sort of, I guess, somewhat proprietary software that's attached to said cloud. Looking at sort of the end-to-end machine learning frameworks that are out there, what that really helps to do is, if you don't have a large team in place, it helps to sort of simulate that large team, right? So it takes in all of your data, and then it helps, because it's all about the data in the end. I was going to say, I'm sort of like the vegetable lady. Basically, anytime you're using data and then you partner it with AI, the quality of the data issues are just going to be exponentially more painful. So starting with really good data, and oftentimes that starts in the cloud with a data lake, or now we're seeing the lake houses, right? So being able to look at something like that, and then what a lot of people I think fall down, like he made a good point with the job doesn't stop with the training the model, right? So okay, great. So you trained a model. What does it actually do in real life? And so these frameworks really help to, I guess, with observability, and that's part of MLOps too. The observability, the governance. How are these, like, have you thought about these things in advance? And if you haven't, how can these frameworks help you, right? So how does my model act in the real world? How do I fix it in the real world? And it helps move that along into deployment. So I think that some companies will be big enough that they will put together their own sort of data pipeline. But I think there's a much larger group of companies that are going to look for these solutions. I think they're still going to need to think through them, but they're going to need the help that these frameworks provide.
So Saumya, how are you trying to work with developers to break through that complexity? And maybe you could give us an overview of OneAPI.
Sure, Alex. Before I get into OneAPI, let's step back and take a more holistic view here. I was thinking, yes, there are a lot of choices and fragmentation, but really what it means is we are really in this exciting time in computing. So there are so many workloads that people are trying to accelerate, a lot of data, like my friend here was saying, and a lot of need for compute, right? Which means one size doesn't fit all. Developers and our data scientists really need to use and make the best use of the diverse architectures, be it the scalar, mainly CPUs, or vector, matrix, or spatial, which we are more familiar calling them as GPUs, AI accelerators, or FPGAs. Now, with a developer standpoint, what we have been observing is they want this all more streamlined. They want to have that freedom of choice to select the best accelerated technology, the diverse architecture, but don't have to deal with the whole code, learning different code aspects, or they do not want to understand the architectural details. So they really want it simplified. They really want to have maximum code reuse and a single tool chain that supports these architectures, so that they do not have to spend a lot of their time, effort, money in order to support these architectures. They can really go from one to the other as seamlessly, and don't have to have like a CPU version of software or GPU version of software, and how do I work with each one here? And that's exactly the vision of OneAPI. What is OneAPI? It's really nothing but a layer of software that delivers a unified programming model. It has a language, namely DPC++, and a set of libraries to help across different domains. We deliver it more as an industry specification, which is open, and we that way other vendors can contribute to it, implement to their different architectures. But at the same time, from Intel, we are offering our Intel OneAPI product, where we provide implementation of OneAPI to exploit the best features of our diverse architectures. Like Intel also has been investing a lot in diversifying architectures and providing a realm of different options and choice. So we want to make sure that OneAPI gives the best performance on these diverse architectures to our developers without having to deal with the software complexities. And that's what OneAPI aims at. To look at it a little differently, people, though they have a lot of choice, which means they don't want to be getting locked into a particular vendor. So they really want to have this freedom where they can choose the best accelerated technology without, and then use a lot of their time and skills into solving real problems, be it the data science problem or the problem of their particular vertical workloads. So whatever their problem is, they want to spend time on that and not on thinking about the software that enables these different diverse architectures. And that's where OneAPI comes in.
Is that a big challenge, Johnny? And how does this idea of a unified architecture play into that? I think he's on mute.
Sorry, the cliched "I am on mute" thingy. Sorry.
Yeah.
So absolutely, the OneAPI strategy and the entire platform looks very promising, because even just using the Intel software stack, there are multiple hardware backends, multiple software layers that we have been dealing with. For example, the Intel community is very familiar with the OpenVINO toolkit, and OpenVINO has transitioned from version 1 to version 2. and it got completely changed. The earlier version of programming the compute stakes and the VPUs was very different till OpenVINO came in. So OpenVINO actually brought in a level of abstraction and made it possible to target a variety of backends, optimizing for CPU, for VPU, and so on. Now, OneAPI is taking it beyond the simpler VPUs and CPUs to the whole plethora of new hardware, like the Intel Scalable Xeon, to FPGAs, to discrete GPUs, to very specialized AI accelerators like the vision processing units, and so on. So it certainly helps developers to basically target the inference and training without worrying about what is the hardware backend that they're actually dealing with. So as a developer, when I look at it from an outside perspective, I think it's very promising.
We'd love to get some questions from the audience, so just please feel to ask away. I want to just turn to Rachel quickly to talk about, what are you seeing as, the most on the edge, so to speak, developments that we're starting to see with scale out architectures? How, what are some of the real kind of concepts that you're seeing taking hold? You have a really great inside view of the world through your work you do at O'Reilly.
Yeah. So deep learning. So a lot of what we, obviously I listen to, podcasts like this and go to events and stuff, but a lot of the insight that we get is from how people use the content on the O'Reilly Learning platform. And what's great about that is we can see the trends sort of evolving. Deep learning, which is sort of like the main sort of way I feel like people are using machine learning software right now, super popular. We're seeing that, but we're also seeing in parallel, I think, with the usage of AI and ML is cloud, people wanting to understand the clouds. And what we've seen now, and I think all the cloud vendors would agree, is that they realize that vendor lock-in is actually probably not going to happen, that there are multiple clouds being used at each company. Some are good for one type of thing, some for another, depending on the project that you have. And so we're seeing people, I think, actually tackling this issue, right, of having to understand sort of best practices and then having to figure out how to deal with that across all of these different choices, which are great. Now, as far as this idea of having sort of this one API software, it's hard, right? So ML is hard, cloud is hard. And so anything that could simplify that process. So I think that's where people are looking at, like making sure that aside from sort of like good data hygiene, how are they making the most of, the cloud and all of these assets, right? And, a lot of machine learning doesn't need to be on like TPUs or GPUs. Some of it can be, a lot of it can be like CPUs are enough. However, the idea that, customer expectations are high. I don't think they understand that they're high in the AI ML area necessarily, but the point I'm making is, you expect an answer on your Apple Watch, for instance, really quickly. So how and where do you process that data and stuff like that? And so I think what's really interesting that we don't talk about that often with the cloud is making those hardware choices, right? And so the idea that you could program closer to the metal, as it were, to grab any sort of like optimization or power, it's that at the edge, it's those restraints, I think, that are going to cause a problem. But again, sort of as we've talked about, embedded systems and stuff like that, this has been an issue that has come up again and again. So it's sort of happening again. And I think we're in a better place to solve it because we have seen the issue. And as we said, it's almost like there's too many choices. So that's where I would leave it.
So maybe we could turn to this question about CPUs, Saumya, and their role. And perhaps you could also then, in this context, provide some clarity on OpenVINO and what is the overlap with OneAPI?
Sure. Yeah, great question and a great segue as well. I hear what Jani and Rachel are speaking here, and pretty much echoes in my mind that, hey, yeah, these are exactly the problems we were thinking while we set out with OpenVINO or OneAPI. To your first question, Alex, on CPUs, in Intel, we have been improving a lot on our CPU offerings, especially with Xeons, where we are making it the most general compute for AI, and we will continue to do that, right? And CPU is a place where every end-to-end pipeline starts. So be it for, in a simple way, the way I look at end-to-end pipeline is where you have your initial data pre-processing stage, which is mainly the data ingestion or ETL processing and data loading, and quickly followed by the feature engineering, model training, model inference, and finally taking into production through deployment. And when I'm looking at this, it's very common practice to start your ML pipeline on CPUs. And we want to make the best use of what these CPUs provide with respect to compute, with respect to performance and memory. There are use cases where we have these AI workstations which offer specifically for data scientists who would like to do everything on-prem for all of their data. Right? So CPU play a huge role there. Xeons, which are part of data centers and on the cloud service providers, are exposing capabilities like deep learning boost and bfloat16, where they are there for more than 80 to 90% of use cases which don't need specialized accelerators. You can do your training, you can do your inference on CPUs today efficiently and effectively without having to move to the accelerators. But of course, there's need for the very specialized and focused workloads which need these accelerators, and hence the whole OneAPI initiative. But CPU is not going away, and CPU is going to be at the heart of this entire pipeline. But now comes an interesting point about OpenVINO and OneAPI. Just a little bit of history. I think Jani summarized it really well. What we are doing today with OneAPI really started 2 years back with OpenVINO. And OpenVINO very clearly and seamlessly provides that abstraction layer and unified API across multiple hardware architectures, right from CPU to integrated graphics, our vision processing units, FPGAs. We also have our GNA, the Gaussian Neural Network accelerators for low power. So all the way from Xeons to the low power Atom chips, OpenVINO supports them with a unified API. And we've seen OpenVINO become a success in the industry. And that's what gave us the confidence to go against this big bet of OneAPI and boosted our confidence that this is doable, right? And OneAPI is really taking this to the next level with a very similar strategy across a breadth of architectures, where OpenVINO focused on a very focused domain, which was deep learning inference. So offer or deliver optimized deep learning inference. Now with OneAPI, we're taking it to the next level where it is addressing multiple different domains. A lot of the traditional software development, be it either on HPC or IoT or rendering, and of course AI, right? And OpenVINO addresses more inference and deployment needs, but there is this whole data pipeline that we were talking about, which has a lot of other stages leading up to training and model creation. And OneAPI has made sure that that area is not left out. Now, how are OneAPI and OpenVINO related? I wouldn't call OpenVINO as something outside of OneAPI. OpenVINO is really in the OneAPI ecosystem. For that, let me explain how our software stack, how we envision the software stack, right? OneAPI at the core is a language and library which interfaces through a level 0 hardware interface into diverse architectures. But on top of this core OneAPI layer sits a layer of middleware frameworks and libraries, predominantly Python, but again, even in other languages, and OpenVINO is one of it. So the key distinction of this layer in the middleware is it uses the libraries of OneAPI and provides the next level of abstraction. And this is where the majority of AI developers sit. They are the framework users. So those who are in the core OneAPI layer are more framework developers who are using the deep neural network library or the libraries which are closer to implementing kernel implementations and optimizing kernel level code, right? But the layer above it, which we call powered by OneAPI, really encapsulates all the goodness of OneAPI and we get it built into these frameworks, be it Intel optimized TensorFlow or Intel optimized PyTorch, or it can be OpenVINO. So OpenVINO, for example, uses the one deep neural network library from OneAPI layer and the one threading building block library from OneAPI layer to get that maximum performance on your CPUs and GPUs. So to all the OneAPI users out, OneAPI and OpenVINO users out there, my word is really, if you're using OpenVINO, you can continue confidently that it is giving you all the goodness that OneAPI has in it. All the performance aspects that OneAPI exploits from its diverse architectures is continued to be exposed through OpenVINO's unified API without the OpenVINO users having to understand what happens under the hood. They continue to be in their unified API layer and work on their applications, but it has the goodness from the deep neural network library, for example, of OneAPI.
We have a few minutes. Great. Thank you, Saumya. That's great. We have a few minutes left. And so I'd like to give Johnny and Rachel each a chance to talk. I'd like to hear from you, Johnny, how you see others attacking this problem, you know, with their approaches as compared to the OneAPI approach with OpenVINO.
So the industry got together and created a standard called Onyx, Open Neural Network Exchange, a few years ago. And Onyx was predominantly created for the same promise that OneAPI tries to address, or the problem area that OneAPI addresses. So Onyx was originally created to create interoperability between deep learning frameworks like PyTorch and Caffe and TensorFlow and so on. And now Onyx is also getting extended to training. So that is one effort that I can think of. And then, of course, NVIDIA has created this layer only for its own GPUs and its own hardware. But this whole CUDA, which is the Compute Unified Device Architecture, and then the cuDNN libraries. And then on top of that, we have the libraries for deep learning and languages that are optimized, frameworks that are optimized for the NVIDIA ecosystem. So all of them come close to what OneAPI is trying to deliver. But for me personally, I think Onyx is a much broader initiative coming from, of course, Intel is one of the core contributors, but Microsoft and even NVIDIA, Amazon, all of them are contributing. So I would actually keep an eye on Onyx and how it evolves over a period of time.
Going back to you, Rachel, just to finish things out, what is it that you're seeing and what developers are really needing now? What are they needing to help take their work to the next step so they can move beyond that one model and they can start thinking about how to scale out more additional models? It must vary quite a bit from
I was going to say that's
different communities. I mean, but there's, it seems like the communities are getting bigger and that is playing a part in the collaboration itself.
Yeah, I mean, communities are getting bigger. I mean, the fact open source plays a huge role, as you know, it has over the past 25 years. I'm glad to see it playing a role in sort of the AI ML world. And because that's like a blessing, because I think it gives everybody a lot to work with. and a curse because it gives everybody a lot to work with. And so I think you have to find what works for you for a specific project. I think that the issues that developers are having are mostly around, so we've seen a lot of sort of things turn towards more data engineering. Like, how do you make sure it's not just about your program, right? It's about, are the pipelines set right? Is the data in the right way? So I would say, like, working with either data or data engineering colleagues, right? And figuring out how that impacts, because that has an outsized impact on the software programming that you're putting together. And then most of the time that's in the cloud. So I think, I think you're best served by going back to best practices, understanding how everything works sort of generally, and then you need to go and you need to make choices per project, right? And I think you should be an expert in sort of how to do things, not necessarily an expert in a particular, API or a piece of software. And that way you should be able to bring everything together and make the right choices for whichever project you are working on now.
Well, I want to thank you all for taking the time to share your thoughts and perspectives with our audience. I want to thank all our attendees here who have been able to tune in to our show. I want to thank Saumya Satish of Intel. Saumya, thank you so much.
Thanks, Alex. It was a great talk.
Rachel Roumeliotis. Thank you, Rachel.
Thanks, my pleasure.
Rachel is Vice President of AI and Data at O'Reilly, and Saumya is a product manager for AI software products at Intel, and Janakiram MSV, principal at Janakiram Associates. Thank you very much, Johnny.
Thanks, Alex.
Okay, well, we'll be back soon for more recordings today. Thank you very much for stopping by. We'll have a full day of discussions on machine learning and how it is progressing in this scaled out world. Thank you very much.